I'll try to be very quick. So this is just an introduction to some areas of research that we've done in the past, and of course we're open to new lines of work and collaboration under this project. So one of the things that we've done before, it's a protocol called Darkube. It's called Darkube because it's based on originally the authentication was based on dark nets. So it's basically a peer-to-peer voice over IP protocol based on multiple hypercubes. So the idea is that you group speakers on a main low latency hypercube, and this improves performance over other over other architectures. So it improves latency and reliability, and it's also very important in a critical infrastructure scenario because you're not dependent on any kind of main server. So this kind of architecture protocol is we've used it for voice over IP and also video conferencing and geo positioning. But it can also be used to, we think it has other possible applications to other types of nodes and networks and other types of payloads. So maybe there's a chance for collaboration there. Another thing we've done in previously, it's the Tangle has function. This was submitted to the SHA-3 competition. It's basically a Merkle-Damgard scheme with a very wide internal path and a variable path dependent on data. It was oriented to 32-bit architectures in the time. We were young and naive back then, and they found not general collisions, but just two messages that would collide in any digest size, and that's too much. So we are probably still naive, but not as young as before. So we're trying to improve the design a bit. We've done lots of the things that we say there, that we need a new message expansion scheme with better avalanche, collision-free round function, and other items. We've done most of them except the round function, and they have been published too. Also, we work a lot in pseudo-random generators and stream ciphers. Basically, we've done stream ciphers based on block upper triangular matrices. These have good performance if you employ set 2, if you are based on set 2 and use some kind of matrix packing, which definitely in the end it reduces operations to binary ops between registers. And recently we had even better performance, that it's really competitive with well, not hardware accelerated AES, but non-hardware accelerated AES is slower, definitely. By using more blocks and different optimized implementation. Nevertheless, these kind of generators are all linear, so they always require a non-linear filter, and we're going to talk about that a little bit later in the next slide, I think. We also work on pseudo-random sequence analysis with the standard testing and other tools we've built ourselves. Also, we've worked on key-derived SBoxes. Key-derived SBoxes are basically random SBoxes that, or random nonlinear functions that are dependent on the key. So they are different on each key, and they are used in many kinds of cryptographic primitives and security protocols. In this case, we are using them to create a key-dependent output filter that can avoid the linearity in standard linearity, so linear pseudo-random generators. And they also introduce the concept of key scheduling to stream ciphers, which comes from the block ciphers. So that's a bit of a different thing there. And we have also developed a custom SBox analysis engine that generates and analyzes SBoxes. We've also done some public key cryptography or public key crypto systems. This is not really my field of expertise, but Antonio, my colleague here, he's done more of this. They're based usually on block upper triangular matrices, and we've done related quick exponentiation algorithms which are needed for this kind of schemes. Key exchange, digital signature. There have been some attacks that have been published, and we are trying to find some solutions with circulant matrices, and we are also cryptanalyzing other matrix-based schemes. We are also doing database security, basically with homomorphic encryption. Well, we have a PhD student working on this, and what he's doing basically is trying to see if we can use NoSQL databases and massively parallel systems like we have today to solve the performance problems, because homomorphic encryption solves many of the security problems, not all of them, because you cannot do all of the queries you would do in a normal database, okay? But it's very slow, and it doesn't really scale well with current technology. So can we use these different type of non-relational databases to improve performance? That's a question we're pursuing. Also, in relationship to Casus, these are my translation to English of the goals of the project. So that acronym is Critical Transport Infrastructures and Emergency Management. So for IT applications, we think that database security is useful. For relevant primitives, the hash, random generators, stream ciphers, public key, these all work well. Improved communications algorithms, well, the dark cube protocol, I think it's a great asset for the project, and that can be built upon. Also for secure cooperative systems based for mobile devices, it has to be told that dark cube protocol is based on mobile devices, was originally based for mobile devices. And database security also is a good fit for this goal. And for the goal of heterogeneous network and technology integration for mobile devices and in critical infrastructures, Darkkube and database security are also fitting. We have also done some publications already under the Casus project, and since in Spain this impact factor thing is very important, we put it there, but it's not really that much. But we are working on it, and we're open to collaboration, of course, and we will, open for new lines of research, and that's it.